Good morning, grade 9. Okay. For Science 9, we are now in the end part of Module 1, weeks 1 to 4. This is the only module that we have for the fourth quarter. I intentionally did this, in order for on the lessons that is actually given in that particular reading period. Okay. Usually, in our previous quarters, we have two modules. These modules, inside these modules are science concepts that we need to tackle and we need to discuss further. Okay. But for this quarter, I already given you a one module. I did intentionally give you a one module or a single module in order for you to focus on the lessons and create a learning material or learning resource material out of it. Okay. How was your learning material?
Still doing it, sir.
Come again, Robbie?
Still doing it.
I cannot hear you clearly, Robbie.
Still doing it, sir.
Okay, that's great. How about others? Okay, reminding everybody also, okay, you need to check on your activities one by one. Why? Because I am still in the middle of recording your roll scores for the fourth quarter. Okay, you check on the activities. We only have how many activities here? We only have 3 activities and 1 performance task here plus 1 project. And that's it. So review on the activities that we have for the fourth quarter and let me know if in case there are some missed activities in order for me to assist you with your missed activities. Okay, let me check on the previous activity that we have, the report sheet. This is your performance task. Again, 40% we are great. Okay, in my screen, I can only see these are the people who submitted their report sheets. We have Andrade, Mintoy. No, Mintoy didn't actually submit it. Rabbi and Jillian, only 3 students. Okay. For the benefit of those who didn't actually submit yet their performance task, their report sheet, I am opening this again for the last time. Remember that your exam is fast approaching. Okay, your exam is 16, 17, and 18. We are now in May 4. Today is May 4. Okay? Today is to prepare, but then again, do not waste the time, do not waste the I have given. I might open this time. Okay? But I will not open this again. Okay? I can only see 3 students who successfully submitted. Rabi?
Sir?
Rabi, I will give you the task to inform your classmates. Performance task, which is your report sheet.
What again, sir? I lagged.
I will give you the task to inform your classmates, okay, that the performance tasks, your report sheet is now open again for the last time. Okay, this will be the last time that I will give a chance for you to do your report sheet. Simply because, again, I am now in the middle of recording your roll scores, and I don't have the luxury of time waiting for your answers. Right? Inform them now in our GC after this class. Okay? Again, the report sheet is not just for online students. This is also good for offline learners or students. So it is now open. Other activities, it's up to you to check on your activities if you are done with your activity. Okay? Other activities like activity 1, 2, and 3, this is good for online learners or students. But activity number 4, which is the report sheet, is good is also good for offline learners. Okay? Do you have any concerns so far? Do you have any concerns so far? Grade 9? Are you still with me?
None.
Okay. EJ, please check also your other subjects, right? Other
Yes.
quarters also, everybody. I am reminding everybody again to check on your outputs or to check on your activities, okay? In the previous quarters that we have. We have 4 quarters in a year, okay? Inside those 4 quarters are activities and performance tasks. Again, the absence of one performance task would mean a failure also in the subject, right? I think that will be all for today, class. Thank you for your participation. I will give you time to submit your report sheet. Okay, do not waste time. Okay, in my clock, it's 8:32. You will still have a lot of time. It is to submit your performance tasks. And then you just give me a reason that, sure, I don't have internet connection. Okay, I had given you ample time. You maximize the time that I had given to you. As simple as that. Okay, no other excuses. Yeah, it's okay. Okay, it's okay that you submit digital output, provided that your digital output will look like this. Let me share this to the class. Okay, let me give you again the example for the digital output. Hold on. Let me share this video again. So you observe on the content of the video, okay? After which you give or you share to the class what you had observed. Okay? This is again an output or project of last school year's batch. Digital output. Since during that time you cannot actually do the physical output yet. Can you see my shared screen now?
Yes.
Yes, sir.
Okay. You observe the contents. Okay? How she actually arranged the contents. What is inside this blog? This is a video blog actually. This is one good example of a video blog. Okay, under digital output.
Hello everybody, it's me, Kaylee Maxine Velosa, and for today we're going to be talking about a very interesting topic, gas laws. Let's start fresh. What are gas laws?
Well, gas laws are examples of scientific laws. These are statements that describe, summarize, and predict a range of natural phenomena by means of repeated experiments and observations. Gas laws are laws that relate variables pressure, temperature, volume, and amount mathematically in order to make predictions about gas behavior, which is given in the kinetic molecular theory. Now, let me briefly introduce to you the gas laws and some of their real-life applications.
Funny
formulated by Robert Boyle in the year 1662. This law describes the relationship between volume and pressure, claiming that the two variables are inversely proportional, which means that when the exerted pressure of a gas increases, the volume it occupies decreases, given that the temperature and amount is held constant. So when one goes up, the other goes down.
Deep-sea creatures are unlikely to survive on the surface of the waters because they are used to high pressure. Once they are brought up, decrease of pressure allows the gases in their bodies to expand, causing their air bladder and cells to rupture.
Charles's Law, proposed by Jacques Charles in 1802. Given that the pressure is held constant, a gas's absolute temperature and the volume it occupies is in direct proportion, which means that what happens with one variable also happens to the other. An increase of temperature causes a corresponding increase of volume.
This law can be applied to baking. If you want your bread and cake spongy and soft, you would need yeast. Yeast is a leavening agent that converts sugars in the dough to carbon dioxide. Once the dough is put into the oven and baked in high temperature, the dough's gas expands, resulting to a spongy soft appearance for your pastry.
The relationship of the temperature and the pressure of a gas is described in a Montan's law, discovered by Guillaume Montans in the late 1600s. Just like the previous law, this law also describes a direct proportion relationship. When the temperature of a gas increases, while the volume is held constant, it causes the pressure to increase too. He discovered this while building an air thermometer.
According to Montan's law, higher temperature results in higher pressure. The air pressure in tires increases as the temperature rises.
Driving excessively raises the temperature of the air in the tires. Doing that, especially in this hot weather, may blow up your tires due to overinflation. Better get your tires checked to avoid risky scenarios.
A pressure cooker is a cooking device that cooks food quickly. While the food is being heated inside, its fixed volume container traps the steam being generated, and as steam builds up, the pressure increases. This law is simply a combination of the three primary laws we just tackled. There are specific events that involves the variables temperature, volume, and pressure. Hence, requiring a combination of the three laws caused the discovery of the combined gas law.
Our lungs are the containers that hold air. As swimmers dive in the depths, they make sure that they know how to adjust to maintain proper pressure balance between their lungs and the water. Because the water pressure increases, and like stated in Boyle's law, volume will decrease. And applying Charles' law, diving in cold waters may squeeze your lungs until there's no air left for you to breathe. Same goes with diving on a warm weather. The volume of air in your lungs may expand quickly. Without exhaling, the air will build up inside.
Proposed by Amadeo Avogadro in the year 1811. This law states that under the same temperature and pressure, equal volumes contain an equal amount of molecules.
When blowing up balloons, the volume increases as you release gas particles into the balloon from your lungs. The balloon's volume will expand as you force more gas particles to it.
Just like the combined gas law, but the Avogadro's law is added. Scientists wanted to study the relation of gas molecules to its environment, but upon brainstorming for the perfect equation, there are always affecting factors such as intermolecular forces. So, they just came up with this gas equation to study gas behavior, despite some minor factors.
Airbags installed in cars is controlled by a sensor that detects a crash. When the car crashes, the controller alerts the system, triggering an inflator that burns chemicals such as sodium azide very rapidly to produce large volumes of gas to inflate the airbag. While this happens, the bag is also being compressed when deployed, decreasing its volume, resulting to its pressure to rise. However, the gases are being neutralized to prevent the bags to overinflate. And seconds later, after the deployment, the bags will start to deflate in order for you to get out of the car.
Lastly, we have the Dalton's law of partial pressures, discovered by John Dalton in 1801. This law states that the total pressure exerted by a mixture of gases is equal to the sum of the partial pressures of the individual gases.
This law is especially applied to atmospheric studies. The atmosphere is made up of gases, mainly nitrogen, oxygen, and carbon dioxide, and water vapor. Put together all the partial pressures of these individual gases, we get the total atmospheric pressure. Now you know the basic concepts and applications of these gas laws. I hope you learned a thing or two from this video, and I hope you understand the importance of these laws. Studying gas laws are important simply because these gas laws apply to our everyday lives. You may not realize the things you feel, see, hear, and smell can be explained by gas laws. These can even save your life. Till next time.
All right, so that is one good example of a digital output under blogging or video blogging. Okay, what had you observed out of the video? What
You
had you
showed
observed?
some examples, sir, to explain the concept
Yes,
better.
basically, the purpose why do we need to have or why do we need to create a learning resource material is for that learning resource material to explain the science concept. Remember that these science concepts are too vast, they're too bad, they're too, shall we say, broad to fully understand it. That is why we are here as teachers to explain it further, and we are here also to guide you all throughout. But this learning resource material will give us an implication that you learn something out of our discussion. That's the reason behind it. It should explain. Again, if you will have the digital output, it should explain the concept. Okay? In that sense, you're going to look at Veloci's output. Um, she actually explains all the gas laws because their topic during that time is gas laws. Okay? Amontan, what else? Combined gas laws. So those are their concepts, science concept. In your case, you need to choose one, okay, science concept. And in that certain science concept, you explain further. You can actually use a lot of videos, resources, but please include it in your credits, right? And again, it should be narrated. As you can observe, she actually gives some examples, okay? She also narrates, okay, the science concept itself. What else? She also provide us the practical applications for that certain gas law, for that certain science concept. Because these science concepts are not just inside the book, okay? It should be applied, okay? Another good example is video documentary, okay? In a video documentary, it would look like this. Hold on. Over this.
Over the centuries, experts have been studying something that is unseen in our naked eyes, and that is gas. And since it is different from more visible things, studying this element is more difficult. For that reason, scientists came up with some things that are helpful for them to study gas itself, and those are the gas laws. Additionally, there were plenty of experts who have formulated their own gas laws, and each gas law has their own uses. However, how can we apply this in our daily lives? Let's find out in this video. This is Christian Inario, and you're watching Science Matters. Studying science is interesting, and this makes us formulate a lot of questions. For this topic, we tend to ask, what are the applications of these laws in our daily lives? To begin with, we will talk about the Boyle's law. This describes how the pressure of the gas tends to increase as the volume of the container decreases. According to the rule, if the volume is large, the pressure is low, because the particles cannot move quickly because they must move in a large container. On the other hand, if the volume is small, the pressure is high, because the particles must move in a smaller container. You can observe a real-life application of Boyle's law when you fill your vehicle tire. As you push air into the tire, the increasing pressure reduces the volume of the air molecules by packing them together, the pressure in the pump has to always be higher than that which is inside the tire in order for more air to be pushed in. As the air temperature is more or less constant in that period of time, you can see a real-life example of Boyle's law occurring in front of you. We are down to our next law, and that is Charles' law. This law describes how gases tend to expand when heated. According to the law of Charles, volume and temperature are directly proportional to each other. A real-life application of Charles' law would be your vehicle tire. If you read your owner's manual carefully, it will mention that tire pressure should always be measured cold. That's because driving around heats up tires. Charles' law states that the gas should always occupy more space when heated. But the tire does not expand very much. This causes the tire pressure to be higher when warm. Consequently, measuring tire pressure when the tire is warm will give you the false impression that you have filled your tires with too much air. Now, we are going to discuss our third gas law, and that is the Avogadro's law. According to this law, the same amount of gases at the same temperature and pressure emit the same number of molecules, regardless of their chemical and physical properties. In other words, as temperature and pressure remain constant, the volume of the gas is directly proportional to the number of gas moles. A real-life evidence of this law is whenever you blow up a balloon. The volume of the balloon increases as you add moles of gas to the balloon by blowing it up. Basically speaking, the more moles, the larger the volume will become. Now, we are in a Monton's law. This law states that the pressure of an ideal gas varies directly with the absolute temperature when the volume of the sample is held constant. This means that lower temperature means lower pressure, and higher temperature means higher pressure. A real-life example of this is your vehicle tire. In hot summer days, the inflated tires of vehicles may burst. The bursting of tires is caused by a Monton's law. The inflated tires are under high pressure. When the temperature of the air rises, the pressure of the gas in the tubes also increases. After an unbearable point, the tires fracture. However, what makes gas law important? Actually, gas law make the studying of gases much easier. They can be used to determine the parameters of a mass of gas using theoretical means. For that reason, these said gas laws are truly of great importance, and I do believe that they are useful when studying the things that are not seen. Remember, there are still gas laws out there not being mentioned here. For that reason, I encourage you to do your research and be limitless. This has been Christian Inario, and always remember that science matters.
All right. That is one good example also of a video documentary. As you can observe, they actually include credits, okay, from the sources simply because they didn't actually own those video clips. It is actually owned by somebody, and it should be included in the video. Okay. However, in your video documentary, as you can observe, Christian Inario also discussed about the relationships. Number one, number two, practical applications again. Okay. Number three, the science concept itself. So that should be included in the video. Do you have any questions so far with digital output?
Done,
None.
sir.
All right. I think that will be all for today, class. Thank you for your participation. Let me record your attendance in a while. We have Rabbi, Hilary, EJ, and Jillian. I think that will be all for today, class. Thank you for participation. Have a nice day, grade 9. Take care. Bye-bye. Enjoy the rest of the day.